This is the Pi 5. I'm going to be using this 2 gig Pi 5 to run leakage.com. It's $85, and that's the cost. Let's go ahead and see if the site comes online. And there it is. So there you have it. Hi everyone, welcome to MacMon.io. My name is Johnny Mac. I am a software professional and host of this channel. I'm really excited to share about a project I just completed, which was to move one of my web apps off the providers I've been paying for and onto a Raspberry Pi running here at my house. You can do this too in under an hour if you follow this tutorial and use the code. Why did I do this? Is it just to prove a point that it can be done? I think we all know that this can be done, right? So what's really going on here? I spoke about this idea a few weeks ago when I set up a LAMP stack app for a client on the Pi. It's about the value you're getting from those PaaS providers for your app. The app I migrated doesn't get a lot of traffic and I can tolerate some downtime, so I decided it wasn't worth the $65 a month I've been spending. I just wanted to see, what does it take to set up SSL and DDNS for an app on the Pi? These are the most overwhelming pieces that people often face. They're, oh, I don't know how to set up my DNS. I don't know how to get my certificates, right? My PaaS provider just takes care of this for me. And that's a testament to the PaaS providers, right? They take care of this for you, and that's great. Many of us are likely experiencing this right now, where you have something set up on AWS or Heroku or Render, and it's kind of stuck there. It's kind of overwhelming. You know, the data backups, that's another piece that gets people. They keep your app up and running, and that's great, but it used to be cheap, like 10, 15 bucks a month, and now it's getting more expensive. How did I end up at $60 a month here? The cost of this home hardware is coming down, the bandwidth is coming down, or I'm getting more of it for the same price. So maybe it's time to challenge this assumption and experiment a little. This app, it's a fun game I created with a small team about a decade ago, and it's called Leagueheads, leagueheads.com. We came up with this idea after we went to Vegas for a college basketball tournament. We were having some fun betting on the games, and we found we were competing with each other for who could win the most or lose the least. So we created this game online called Leagueheads. Basically, it's been humming along. I want to keep it running. It's a Rails app. I started on version 3 of Rails over a decade ago, and I have done well to keep that up to date. But it also runs MySQL, and I have not touched that. It's literally running version 5. In this upgrade and migration, I did finally get around to upgrading the database to MariaDB version 11. I thought the most challenging part was getting that dynamic DNS as well as SSL set up, ensuring that those certs are automatically renewed. It wasn't that bad. Once you get that set up, and I've done a lot of work for you here, a lot of that nuanced work of making sure that the certbot is set up and that Nginx is set up and that you can retrieve that initial certificate and then get your app running. I found a great free provider for dynamic DNS and a great client that will update your IP. At the end of the day, the app was running on Heroku. The database was still in an AWS EC2 instance, and now it's just running here on the Pi. So to prove it, I'll just make sure you do believe me. We're going to go ahead and ping leagueheads.com here, and you can see the IP there. If I come back to the browser, you can see that what's my IP address? It is indeed 76.95.182.81. So this is running from here at my house on the Raspberry Pi on my desk. And we'll go ahead and get into how did I do it. Okay, we're going to take some notes. What do we need to worry about? Let's hop into XCaliDraw and take a few notes. We need to worry about DNS. We have a Heroku app that we need to somehow get over to our Pi. We have MySQL data that we need to get over to our Pi from EC2. We have to worry about SSL certificates and renewal. Okay, so why don't we start with that DNS, right? Let's suppose we have some customers that access the app through the phone. We may also have customers accessing through a laptop or a desktop. They're going to go to leagueheads.com, and what's going to happen? That request is going to go to whatever ISP they are being managed by at that moment. That ISP is going to route that up to a root server, which is going to manage, okay, this is a .com domain, so I know about .com domains. I'm going to get you some more info from what's called the top level domain server, and that's going to be getting information from what's called the top level domain registry. So really that's what is important. We'll just refer to that as top level domain registry. And this is ultimately what we're gonna wanna update. Right now we have, let's come back to our notes. We're managing DNS with GoDaddy and Route 53. Currently, the domain is registered at GoDaddy, and GoDaddy has its name servers pointed to AWS Route 53, and it's set up to route the CNAME to Heroku. Okay, GoDaddy will be kind of off here. It's not in the chain necessarily at runtime, but I do need to update GoDaddy so that it's gonna get some new information about where to look. So then what's gonna happen is you're gonna have an authoritative name server, and that's Route 53 for me. We're gonna change that so that we can update easily. We're trying to eliminate AWS completely. I discovered a service called Dynu, right, or Dynu, and forgive me if I'm saying that wrong, but that's how I understand it. This is gonna tell you what IP is actually serving this application. That's gonna go to your ISP, and then that's gonna go into a router, and then for us, ultimately, this is going to go to the Pi, right? Heroku has a router. It sends requests into the app running on their control plane and then sends the response back to the client's mobile device. But we want to change that so that it's going to be served off of the Pi. This is basically what we're looking at. The areas that we want to make changes, right? We want to tell GoDaddy here that, you know, hey, there are new name servers, okay? And we're gonna update those new name servers to this service that I just mentioned called Dynu. And then here in our router, this is gonna be our home router. And so we wanna make changes here, okay? So that traffic coming in to this router, right? Incoming traffic routed to the Pi. Because internally on my home network, that single IP from the outside is now broken up and spread out across all the devices in my home. And one of them is running my service. And with those settings, I ought to be able to get traffic coming from my phone to leakheads.com and ultimately being served off the Pi. So let's talk about Dynu real quick. So Dynu is free DNS, dynamic DNS. One of the issues here is that as your ISP at home is managing your internet access, it's configuring and providing you with an IP address, and it's not guaranteed. It's called dynamic DNS, and it's going to change. Now you can buy an IP from them that will remain the same always. It's called a static IP. People do that, but it's a little more expensive because it costs them more to maintain that IP for you. So what we can do instead is use the default dynamic IP, but then we're going to run a client on our device that is going to check periodically if the IP provided by our ISP has changed. Right now, my IP address is here, but if that changed, my app won't work. Okay, so when we come here, you see leakheads.com. I went ahead and created an account here. It's totally free. And then you can just enter your domain and it's going to create a record for you with the IP you currently have at that time. But that's going to be fixed at that moment. And later, if it gets changed, my ISP, I need to update this record. And so I'm going to run some code on the device that does that. So hopefully this makes sense. Then here on my router, I'm going to come in here. First, you're going to look for your local area network setup. I want to reserve an IP in my home network because I want to configure port forwarding for external traffic coming to my app. Make sure it always routes to the same IP. I'm giving this device a static IP on my home network. The other thing that we want to do is find in here, usually in advanced setup, is port forwarding. Port forwarding is what is going to allow traffic coming into my home to be routed to a specific service on my home network. And so then we're going to map that to the device IP that we just set up. Now, what do I need to do next? For GoDaddy, specify these name servers: NS1, NS2, NS3, NS4, NS5, NS6, right? Dynu.com. Very easy to set up and remember. And you just go ahead and put these in for the name servers. That's gonna get us the traffic into that. Next, we have to figure out how do we get the Heroku app running on the Pi. Think about how this app is configured. So we have our app, we have a DB, right? Then think about we have a cron job that runs and it's going to call out to get some data. In this case, it's for lines for games and scores. How might we set this up? Currently on Heroku, I deploy an application. It spins up a small container and runs that application. When I restart it or stop it, any data persisted to the dyno running is going to be lost. The data is in the database, which is on an EC2 instance running MySQL. So if we're trying to take that model and run all that on a Pi, I need to think about how can I modularize this. If we recall back to the video I made on the LAMP stack, I was actually running the database and the application natively on the device. We could install Rails, install Ruby, and then install MariaDB on the device and get that set up. However, I already have this Docker file. This is a Rails application, and I already have this Docker file. I use this to do some local development. I have modified it slightly for production, but my thought was, why don't I use Docker Compose to organize my services and run them on the Pi? Let's experiment with that model and see what happens. And then we can put Nginx in front of that, right, to terminate SSL, because I know that Nginx is capable of that. One thing I'll note is that we do install the Ruby base image for 3.3. We install a few dependencies. Yes, we do need these dependencies. I run bundle install using the gem file. And finally, I'm going to run and precompile assets. This is logic that I would want to probably have a separate production Docker file for. I haven't done that yet, but I'll do that in the future. And then I also have this rake non-digested assets because I didn't have time to deal with using helpers all throughout my code. Okay. And then finally, we're using Tini to manage the processes that run inside the container. The other thing I want to draw your attention to is you do want to take note of your database configuration so that you can set up your database as a Docker Compose service in the same form that your application is expecting. In your config database YAML, you're going to want to take note of your database name and the username and password that is set up for the database there. I did import it and wanted to maintain that model using the Heroku model proc file. Foreman's going to let me use that. This is an old utility for Ruby on Rails applications that is going to configure a cron tab for you with a nice syntax and sucker punch for these asynchronous events that I need to run to send emails and that kind of stuff. You can see this is an old gem file, like it's been through the years. Look, we have Capistrano here and 13 years ago, initial import. This is an old application that we're just bringing along and it keeps going. One thing I will note here is that when we start our app, we're going to clear out any lingering PIDs from a previous run, and then we're going to run this bin prod. This probably doesn't exist in a standard Rails app, so I did create a bin prod using Foreman to start the app, referencing my proc file, and I'm hard coding port 3000 because I know the port. Heroku is going to randomize that port, so you're reading that from a Heroku environment variable. But in my case, I know the port because I'm in control of the environment. So I'm just going to hard code that to port 3000, okay? And so those are the changes I made to the app. Other than that, it's a standard Rails application. I have my models and my controllers. These models are going to be referencing those database tables. We should be good to go with this. I'm just going to build this the way I would build any other image with Docker Compose. I'm just going to Docker Compose build. It's going to run through the commands in the Docker file and build me an image. And now I'm going to have that image locally. My new way of deploying is building an image locally. Now I need to get that over to the Pi. So if we come back to our Excali draw, we're going to use Docker. We're going to have Docker and images, and then we're going to ship those over to the Pi. Then run them on the Pi. So what does the Pi need to have? The Pi needs to have Docker, right? That is a dependency now that we have created, and we can say that needs to have Docker installed, okay? So we're going to have to make sure that Docker is installed on our Pi and we're able to build images, and then we're going to have to figure out how to ship them over to the Pi. So now we have our image, and what we need to do is configure the RPI. We need to configure rpi-image-gen to generate an image for us that will allow us to run this Docker image that we just built. And while we're thinking about that, we might want to also ensure that it can run a database and that it can configure our Nginx layer to procure our SSL cert. Okay, so I've bootstrapped this application. We have a Docker file here, and this is going to create a container image that we will use to run rpi-image-gen, right? This isn't going to be creating anything for our application necessarily. It's going to be creating an image to run rpi-image-gen to generate a Raspberry Pi image that we will then load onto an SD card or a USB stick and put into our Raspberry Pi, okay? Then Docker Compose, we're going to mount the custom RPI image layout. And this build script is going to run the image in a container, then run rpi-image-gen to generate a Raspberry Pi image. That Raspberry Pi image is then going to be what we put on that SD card. The Docker image runs rpi-image-gen. This script executes that for us and then cleans everything up, so there's no lingering artifacts left over. I'm going to name this image RPI prod Rails app Docker. If we come into our image layout, you can see I have also modified the device hostname. The device user is going to be Leakheads. I'll populate this password as well as the Wi-Fi information. I set up Wi-Fi only temporarily because I want to be able to work on this from my desk and I don't have the router nearby. Ultimately, I'm going to remove all the Wi-Fi configuration from the RPI image so that it's just not even accessible over Wi-Fi. Okay, so then if we look in our meta, we have our customizations layer. This is going to install something important, which is DD client. This is going to be used to update the Dynu DNS. Avahi is going to be used just to broadcast the local hostname service so I can access the Raspberry Pi from my host machine over the local network using the hostname instead of the IP. And then also fdisk so that we can resize the root partition when the device boots. Okay, and then this is for that Wi-Fi networking. We have our firmware and network manager, and we're going to hook up so that we can sync the time. That's what this does here. In our image, if you've seen this before from some of my previous videos, we have our Wi-Fi setup. Again, this is going to be temporary, as well as resizing the root partition. This is really like the boilerplate that we're going to use to begin with. The meat of this image generation is in installing Docker and making sure that we install the necessary components to run the application using Docker and get SSL certificates installed. If we look here at the profile, a great way to install Docker in your Raspberry Pi image is to use this layer provided by rpi-image-gen. So you have app container, Docker, engine, bookworm. This is going to give you everything that you need for Docker to run on your Raspberry Pi. Okay, so you just plop that right in to this location in your profile, and you'll have Docker installed on your Raspberry Pi. Then we added our customizations and Wi-Fi networking. The next thing we want to do is make sure we have some configuration for Docker, and we're going to use Docker Compose for that. Okay, so we want to make sure that we install a Docker Compose configuration file that Docker will use to set everything up and run the services that we wanted. Our application, our database, and Nginx. If you're not familiar with Nginx, it's a layer that we run in front of our application. It's a web server that can terminate SSL and load balance if we wanted it to. So we could run multiple services for our application, balance the traffic coming in for those services. We're not going to do that in our case. We're going to use it to terminate SSL. The next thing we're going to do is create a Docker Compose YAML file. I did show you earlier a Docker Compose YAML file, and it was in the Leakheads application code. And I think I want to move it here because this is a better place. I'm going to need that file to live. I'm going to be building the Raspberry Pi image from here, and I want to install that file here. So I think this is a better place for that to live. We're going to create a new directory, and we're going to call it Rails app Docker Compose setup. The name doesn't really matter. This is just the name that I picked. the Rails Docker Compose setup. Okay, and then in here, we're gonna have our Docker compose.prod.yaml. Okay, and this is where we're gonna start to configure our application. Let's start off with the code that we want to have running here. The first thing is we want to make sure that we are running Nginx, the application, and the database. Let's go ahead and show you what that looks like. Here we have Nginx. Now I'm creating a profile. If you're not familiar with profiles in Docker Compose, this is going to allow me to associate services together. By default, they're all associated together. If I specify a profile, then I can associate services together in that way. So all of these three services are going to be associated together through the app profile. And then I'm going to mount some volumes. This is important because this is how Docker is going to be able to persist data. When the container shuts down and starts back up, it will have access to that persisted data. Okay, so that's what this mounting is enabling us to do. We're going to mount these specific directories. This is going to hold our Nginx configuration here in conf.d. And then this is going to be where we're going to store our certificates. Okay. And then we are also going to install my MariaDB, right? So we went with version 11 here, and we're going to expose that through port 3306. Okay. And then again, we're going to mount a volume here because the data we want to make sure is persisted to disk, that it doesn't, disappear when we restart the application. Okay. And then finally our app here. So here we're running that command for bin prod, right? And that's why we had to create that bin prod file in our app. We're setting our Rails and rack environment to production, mounting a volume again, dependencies, right? So the app depends on the database. The database doesn't really depend on anything, and Nginx depends on our application, okay? Restart unless stopped, so that these two restart. That's pretty much the gist of it. Now we want to add a network because we want to make sure that all of these apps are communicating over the same network, and then we're also going to define our volumes, okay? We're getting really close already. What we want to do now is think about something. I tried this and I ran into a problem. If you want to have a certificate issued, the way that works is that the cert bot, which we'll add here, is going to make a request to Let's Encrypt. It's going to ask you to do that for a specific domain, okay? And then it's going to issue a challenge to that domain on the unencrypted protocol. When it does that, your application needs to respond with the expected response so that Let's Encrypt knows that you are in fact the owner of that domain, okay? So that seems straightforward. Well, the problem is that Nginx is going to expect us to start up on both ports, 80 and 443. And it won't let me start up on port 443 unless I have a certificate already, okay? I'm gonna save you a lot of time because I found a nice, elegant solution to get us through this. So what we're gonna do instead is create some init services, okay, for both Nginx and for certbot, all right? So what that looks like is very similar to what we have already, except we're gonna limit it in a way, okay? So we have Nginx init. This is going to run a init configuration file, which will not start our server on port 443, okay? Only on port 80, all right? And then we're gonna have an init certbot service that's only gonna run on that initial boot of the application when we are setting up the device. I've wrapped this in a script that we'll introduce in a minute so that it's kind of abstracted and you don't have to worry about it. Essentially, this is gonna let us run that first certification request without having an issue starting Nginx, okay? And then once that initial cert is issued, what we can do is have certbot run under its normal mode. We'll add another service called regular certbot in the app profile. Every time this app profile runs, certbot will run. We'll create a service that will run certbot on some cadence to check if it's time to renew the certificate. We'll use certbot in the app profile to do that because we'll have Nginx running on port 80 in this profile. Nginx was able to start after that initial certification was issued, so that's all good. We just need this init profile so that we can get through that first time. Unfortunately, that means we need to write some scripts. Let's start with what we'll call manage cert.sh. Essentially, this is going to run a check to see, do we have a cert or not already issued? And if we don't, we'll go ahead and run this init profile, right? So we'll Docker compose, we're gonna reference our Docker compose YAML prod file, and we'll just run that init profile, and that's gonna start Nginx without the SSH support and, SSL support, and then run certbot to retrieve a certificate, okay? And from that point forward, we'll have a cert, and we will just run the normal profile for certbot, and it will then renew the certificate and then reload Nginx, okay? And so that's what that looks like there. Now, we do need to make sure, right, this Nginx SSL directory, right, that's gonna come here from our configuration. And then within this, we have a directory called Nginx and another called, and then within both of these, we have a default config file. And the way that we tell Nginx which config file we want is that we mount this directory. For the init, we're gonna mount init, and it's gonna find this configuration. For the regular Nginx, we're gonna mount this directory, which is gonna find this configuration. And so that's how we are able to have our cake and eat it too. This is what it looks like to run this one server running on port 80. Nginx, in absence of a cert, will be able to boot up with this configuration because it's not expecting a certificate. However, for the normal mode, we're going to need to make sure that we are booting up and also starting a server on port 443 that is going to expect a certificate, okay? And so that's how we're managing that initial setup in a graceful way. I'm really pleased with this solution. It's pretty slick in my opinion. This is where we'll pass off to our application. If you're not familiar with Nginx, you don't have to get caught up in the specifics. You ought to be able to follow along here. Finally, we need to make sure that all of this is actually getting copied into the image. So we're going to write a script for that to customize Rails app Docker compose, okay? We're going to create these directories that we are dependent on. We're then going to sync this Rails app Docker compose setup, everything in this directory here, okay? We're going to sync that over to our home directory for our device user, which is leakheads. Remember, we set that down here. The device user is leakheads. On our Pi, the home leakheads directory will be that home directory. We're just going to copy everything from this setup in there. So we have Nginx SSL, which is going to include the init and Nginx, and then we have our Docker compose prod.yaml. Finally, we're going to copy some environment variables for our MySQL database. We want to create these in our config, in our options, right? We have domain, we have MySQL root password. Domain is what we're going to fill in here in our managed cert. You just populate this options file. So this is where we set the www domain for our certificate, right? So we're going to set that to leakheads.com, okay? And then MySQL root password, I'll fill that in a minute. We also have the MySQL database. We want to make sure that it's the same as what we have in our database.yaml. In this case, that database is called leakheads. And then we're going to be setting up a MySQL user. This is the user from your database YAML, okay? And then finally the MySQL password, which is going to be for this user, okay? And I'll fill that in a minute, what's in your database YAML, or however you've populated that in the past, right? You want to retrieve that password, and this is where that's going to go. If you're nervous about storing this in source code, you don't need to commit this project. However, if you were going to do that, you would want to use some password encryption here. This is going to be a file that's sensitive in general. We've found in previous videos as well that this is a file that's going to be sensitive if we're having passwords in it. Okay, then what we're going to do is make sure that we set permissions. These certbot directories need to be owned by the root user. The last thing I will share is some scripts that I set up to manage a few things. So we have the manage cert script that we talked about, but I also created a few helper scripts. We have a start, stop, and a restart. And we do want to make sure that the permissions are set on those files. So we can do that here programmatically. We want to just use a find here to iterate through and locate all of the shell scripts, and then set the permissions to read, write, execute, okay? For this device user, okay. Shell scripts, and we're just going to Docker compose reference our prod YAML file, which should be in our home directory. And we're going to run this with the app profile and run it in the background. To stop this, we will just run Docker compose down, okay, and restart is just going to be invoking these two so that it's a little helper for us, okay? Okay, excellent. And with that, we ought to be able to build this image, and when we install it on the Pi, we should see it. We're going to have to copy our container image over and load it into Docker. So there are a few manual steps, but that's part of the deployment process. Okay, so we ought to be able to now build a Raspberry Pi image. All right, and it's done. And I am very dizzy. So that's great. So now we can use rpi-imager to install this onto our USB stick. Let's do that next. There was one additional config that I did want to share that I made before building that image. I added an additional option here, device SSH user. This actually was brought to my attention through a ticket that was opened. I discovered that this is the cleanest way to add SSH. Just add device SSH user 1 equals Y in your options, and rpi-image-gen will go ahead and bootstrap the SSH support for your image. Okay, so we have our USB stick. Put that guy in. I'm persisting out the SBOM too, which is great because now we have an SBOM for this image, which we will maybe utilize at some point in the future. Okay, so we'll take our USB here and we'll pop it into our Pi here, okay? And this is my little Pi 4. It's got a screen on it, but we're not gonna worry about that right now. Then when we plug it in, power it on, we should see it boot up and start broadcasting leakheads.local. So if we come here to our terminal, should be able to ping leakheads.local and see a response. It's when it boots. And there it goes, right? Okay, great. So now we ought to be able to SSH with the user we set up, which was leakheads at leakheads.local, and the password. Fantastic. Okay, so now we have successfully set up an SSH client and we are logged into the device. Let's see if we have Docker installed as we expect. Great. And let's see this home directory. This is everything that we had expected. The certificate scripts and our Docker Compose production YAML, our Nginx SSL directory should have our two init and Nginx, as well as the certbot and public that we'll put there. Great. Now we are ready to see if we can't run our app, but we don't have our app. We have Docker, but we don't have the container that we had built earlier. So how are we going to resolve that? The way to resolve that is we're going to first generate a tar file from the container that we built, and then we're going to SCP that over to the device. Then we'll use Docker load to load that tar file into the local Docker registry. Let's go ahead and walk through that process next. Okay, so we'll pop back over here to VS Code and we'll use the terminal. Recall we built the image. We're going to use a Docker command to generate that tar file. We use the Docker save command, specify the destination, and give it the name of the container image that we would like to save. Okay, so here it is, Docker save. Output goes to, I'm going to create this leakheads images directory and put a tar file there and tell it that I want to save the latest version of the leakheads app. Okay, and so now it's going and doing that. And once that's completed, we can SCP this. So if we come back here to images, and we should be able to SCP this file over to the Pi. And I'm going to go ahead and do that. And that's going to be at leakheads.local. Right? And we're just going to put that in the home directory. And it's asking for the password. So now we're copying this to the device. There are other ways that we can do this. We could publish this container to a registry in the cloud, if we wanted to do that. And we could consider that, but this seems reasonable. Again, this is an app that I'm administering mostly locally here at home. I don't need to get too complicated with things, and I just want to make sure I have a deploy flow. I'll be able to build an image, copy it over to the device, load it into the local registry, and I should be able to run it. We hop back over here to our terminal where we have an SSH session. Let's now go and see if that file arrived. It did. Fantastic. If we head back to our notes from the earlier part of the video, we've now mostly gotten this complete. We're sending Docker images to the Pi. Docker is installed. We have Docker Compose config, our init, services, and app services. All right? Let's make that a little bit more easy to read. Okay, great. And let's see what happens when we go ahead and try to start this application. We want to run this init process, okay? If we look at that again, this is going to check for the presence of a certificate. If it's there, it will run a renewal. But if not, it should run these services for us, right? Which is Nginx that doesn't try to launch a server on port 4443, and then it runs certbot and init, right? So let's see if we can run that here. I showed you this earlier, but the site can't be reached because I took it offline. And what we should see is that it comes back to life when we do some work here, right? Okay, so it's pulling the cert container image. That's great. It's pulling that Nginx init container image. Excellent. So far, so good here. And let's see what happens next. Okay, so theoretically, we should now have a certificate. And if we look in the location where we expect that, we see that we don't. Okay, so let's see what happens if we run manage cert. Okay, it's pulling the containers. Great, started. Waiting for certbot to complete. Hopefully that completes. Great. And now if we look in our we should have certificates now, right? Pretty cool. And we can rerun this manage cert operation shell script over and over, and the next time it's going to try to renew, right? Which is important because Let's Encrypt doesn't like it when you keep asking for initial issuance. It wants you to renew, and it doesn't want you to renew unless you are ready for a renewal. It's going to give you that feedback, okay? So we have our cert now. Let's see if we can start our service, okay? MariaDB. Okay, and of course we can't because we don't have the app container image loaded into the local repository yet, okay? And so that's the issue here. So what we want to do is we want to run docker load, okay, -i, and then we're just going to pass it our tar file. What was complaining is that, you know, MariaDB and also Nginx are going to be dependent on this app to be running, but it wasn't available to run. Docker was telling us, hey, this isn't an image that exists. It's now loading the layers from the tar file. Excellent. And so now we expect, if we come back here, we should see some kind of error and not this one. And sure enough, we do. Now this is the Nginx error. Our app should start, right? So now we're seeing a Rails error, and it's in production mode, so we don't see the actual error, but it has to do with the fact that our database, while it's running the MariaDB, we haven't actually created the necessary schema that we need for this application to work. So that's what we'll go ahead and do next. But if we come here and look, we're starting to bang out this list, right? We've got the Heroku app, we've got the DNS, we got the SSL certificates and renewal. We're moving along here if we want to cross these things off. Okay, cool. And there we go. So this is what we have left. And we'll keep moving here. We're almost done. Okay, migrating this data was really easy. I'll walk you through what I did. Basically just use MySQL dump to connect to your database. Mine's running on an EC2 instance. This is the IP of that EC2 instance. You can locate this in the AWS console. If you're running RDS, this should be made available to you through that interface or wherever you're running your database, right? And then specify the user and the database. This is an odd abbreviation for the database name, -p. I don't know the origin of that, but that's the database name. And then these are the conditions. Single transaction, include routines and triggers. I don't think I have any routines and triggers, but I just went ahead and added those, and then I'm dumping that out to one single SQL file. There are other ways that you can do this, that you're just going to, you know, have a table specific dumps, but I went for the one big dump. And so what that's gonna leave you with is a file. However big your database is, it's not anything complicated, it's just a bunch of SQL statements. So then we go ahead and SCP this file over to our pi, the same way that we SCP'd that tar file earlier. And then it ends up on our pi. And here we can see that. And so what I'm doing then is I just made a copy into that MariaDB data directory, right? Because that's what we're going to mount into the MySQL container instance as a volume. But if I put it in there, then I ought to see it when I run the MariaDB instance. And so the way to do that is I can just run, or why don't we just do this from the home directory so it's a little bit easier to follow. Okay, and then we specify the profile app. We're just going to exec, right, on the MariaDB service bash shell. Okay, that gets you in here, and then we ought to be able to locate that SQL dump in the volume that we mounted, right, which is in, I believe it is MySQL, and there it is, that db.sql file. And so what we can do then is we can load that into the database, and the way that you do that is you just specify your user and your database with -p, and then you're just going to use this symbol here. Actually, I think it's that one. And then you reference your data file. That command is going to run and load your data into your database. Once that is complete, then you should be able to run your application. When we do that, what we see here is that instead of an error, now we get our application loading because the database is now online, and that's one thing that is checked on this page when I start my app. And now I should be able to log in because the data is loaded. So my users are all loaded. Okay, and sure enough, I can. There it goes, log me in. Okay, cool. And this, it's launching me into, okay, this was a competition, the LH Ballers League, but I can come in here and show you this was a league that I just completed from the past NFL football season. These are all my friends here. A fellow and his son made it to the finals and had a nice time playing each other. We placed bets on the games. It's not real money. That's one of the fun things about it. It's play money, but you're still competing with other people. And in this case, it was my friend, Mr. Mike, and his son, Chaz, who made it to the finals. I made it to the semifinals and lost to Chaz. Okay, so now what we want to think through is, where are we, right? So we were able to complete this task. Fantastic. And now I just want to add here so we don't forget about it. We want to make sure that we have the DDNS update happening. If that DNS changes, then we haven't set things up to update it automatically. We need our cert renewal to be running on some cadence. The certificates are checking for a renewal. That's not set up. We have the code, but we don't have the worker to run. And we need our DDNS update, and we'll be good to go. Let's figure that out next. Okay, so this was also not difficult. What we are able to do here is looking at the DD client docs. It's pretty straightforward. You have these two commands, system control enable and system control start. But before that, we want to make sure that we edit our DD client conf. Looking into it with the Dynu docs, it's at etc.ddclient.conf. They give you a nice template for you to add your conf file to make sure that it works. So we've gone ahead and done that. If you go onto your Pi, you can locate this file. You can just use this template right here, drop that in. If we look here, right, this is what is going to get updated automatically. And so that's all set then now, because remember back on our board here, this is what needs to be updated, right? This authoritative name server, this is Dynu. If we just say that this is now Dynu, then our Pi is running code to update the IP on this authoritative name server, right? So that's pretty awesome, and that step is done. So we have this now completed, and the last thing we need to do is the renewal. Okay, let's walk through that. We're gonna set up a systemd service that's gonna run that manage cert script that we wrote. Recall we had that manage cert script. We can take a look at that to remind you. So we have this manage cert script, and this is just, if you recall, we ran this, right, to initialize the certs, but we're going to use this same script to run the renewal. It checks for that cert, and if the cert exists, it's going to run the renewal instead of running that initialize, right? Okay, so great. So let's go. For this, we just create systemd service, and that's going to look like this. This will be in the repo code. What I'm going to do is go back to rpi-image-gen so that this is just all set up for you, including that Dynu DNS script. Okay, so this is gonna get dropped in right here. We're gonna have this renew cert set up. This is the service. We're just gonna invoke this manage cert script with the device user. We're also gonna set up a timer, all right? So this is that timer that we're gonna set up, and it's gonna run every day at 3 a.m. and check and see if we need to renew the cert. When we look at how this works in rpi-image-gen, at the end of this script that we have to set up the SSL stuff, you might recall this, we just add, we're gonna copy this service and timer over to systemd system. Just go ahead and populate the device user with what we have in our options file. And then we're gonna enable the timer, right? We just need to enable the timer, okay? So let's go ahead and look at what that looks like over here then. We have the service, and then we also have our timer, right? This is on the Pi, right? This is what it'll look like on the Pi. And then we can test this. So we can go ahead and invoke the start of this renew service. And we can see it's gonna ask for a password, and then it's gonna run that. Okay, so the timer now is gonna manage this for us, right? So with that, we should be all set, right? So we can come back here and we can cross off this last piece, guys. I guess there's only one thing left to do, and that's to box up our Pi and put it into the closet where it will live. So let's see if we can do that. All right, we're back at Micro Center. Pick up some cool stuff. All right. This place just makes me feel really good. All right, I'm gonna pick up some cables here, 5-pack, $9. All right, and we're back. So let's see all the options here. Cool. Wonder if they have that PoE hat. You know, they have some kits, and let's go look around here, see what we can find. Okay guys, so we're back from Micro Center, and we picked up a few things. I got this little case here, $10. It's the standard Raspberry Pi case, and a lot of you have probably seen this, right? It comes with a little fan, so that's cool. I don't know how loud this is gonna be. We'll find out. And then I also got a PoE hat, okay? But, you know, and this thing is $20. So the idea here is that you pop this on top of the Pi, and you can power the Pi with the Ethernet cable. So this is great. The problem is my router does not support power over Ethernet. You need to double check that. If you have a newer router, or if you have a switch that has powered Ethernet support, then you're good to go. But if not, that's something I'd look at. Now I have this, so this will be fun to use for another project, and I need to get a switch that can support power over Ethernet. Cool, so you get this little heatsink here. I was asking the guy about this. He was helpful, but not super helpful. I was asking about little heatsinks, and he didn't seem to know about these. This is the Pi 5. I'm gonna be using this 2 gig Pi 5 to run leakcase.com. There's no hardware here. There are screws or screw holes. So to power, there's a little power port down here, kind of right behind this USB. You gotta pull this little prong off of it. Okay, so I got it in like this with the Cool Cox logo pointing down. It came on, the fan did, anyway. And it went off. So fan options, fan connector, as the temperature, the fan reacts in the following way. Below 50, the fan does not spin. Hopefully that will be sufficient then. Now it's working, it's plugged in. The next step, we're gonna pop this into the closet and then plug it into Ethernet. Okay. Sit in here. Some of you may have a situation like this at your house. This is what my situation is. Some of this stuff is dated, but it still works. I have a Netgear NAS there. Cable modem, router. It's a little dark in here, sorry about that. I'll get some better lighting. But let's go ahead and plug this guy in. Okay, so we got some light now from the camera. I got it all hooked up here. and it's chilling. It looks pretty comfortable. And let's go ahead and see if the site comes online. And there it is. So there you have it. It's tucked away now and it's safe. And we can still interface with it the same way that we were before. So it's not like it's inaccessible, you know? It's just over here in the closet. So that's pretty cool. Okay, so let's just recap your final breakdown. We have the Pi 5 in this case, but you can really run it on a 4. That's $50. We have power cables. Now I didn't get to use PoE, but that's probably about the same price here. And this was maybe $15. I think it was $10 for the little adapter and about $5 for the USB cable. I used USB in the end. That's faster and I don't need the profile to be slim. This was only $10 for 32 gig. Let's see, I'm trying to think what else is in there. Our case, right? This is 10 bucks. And that's about it, right? So in total, it's $85. And that's the cost. If I'm paying $60, $65 a month, I'll recover this in a little over a month. Sure, it's not the exact same situation. I need to worry about, you know, my data backup. I need to worry about, you know, load, if it can handle, if I get a lot of traffic. What about DDoS, distributed denial of service, if someone's coming after my website? These are things I have to engage on. But for a project like this, to figure out if this is possible, not only is it possible, it's relatively straightforward as long as you have a good sense about yourself. And I've done a ton of the work for you here, so take advantage of that. So that's it for this video. Thanks for tuning in to learn how to migrate your Rails application off of a PaaS provider like Heroku or Cell or AWS. We also set up the dynamic DNS and our SSL certs. That's the most intimidating piece. That's what gets a lot of people. They're stuck in their PaaS provider and like, oh my gosh, how am I going to set up SSL? How am I going to get DNS working? I got to go and do port forwarding. And yes, those things are needing to be done, but they can be done and they're not that overwhelming. You saw the cost of this. I'll be in the green, and that's a good thing for a site like this. But there's still stuff that I need to worry about. I'm gonna take that stuff seriously, but I'm really excited about getting this project out to you guys. If you like what you're seeing here, please like this video. Subscribe to the channel if you like this content or consider subscribing. Share this content, I would really appreciate it. Let me know what your thoughts are. Are you trying this? Is this something that you've seen done? Is it no big deal? Or is this something you're genuinely feeling like may have some potential? Don't stop experimenting, challenging assumptions, and seeking the objective truth. I'm Johnny Mac. This is MacMind.io.